Hi everyone, this is Emmanuel from Answer Seekers and Information Sharing.org. So today we're going to take a look at space-time and gravity. What is gravity and what is space-time? We're going to start with gravity. And when we talk about gravity, you must include Sir Isaac Newton and Albert Einstein. According to Sir Isaac Newton, he said gravity is the pull or the force of attraction between bodies. For example, the moon and the earth, the sun and the all planets. Let's look detailed form. Um, Isaac Newton created the law of universe of attraction, the Newtonian law of attraction, which says force of attraction between bodies, especially two bodies, is directly proportional to the product of their masses. Let's say body 1 is m1 and the second body's mass is m2. The product of their masses will be m1 times m2, but inversely proportional to the distance between the body, and that distance should be squared or be inversely proportional to the square of the distance. Okay, let me explain this. The force will be more when the product of their masses is huge. For example, let's take sun and the planet. Let's take the sun and planet Earth. The force of attraction is very huge because these bodies are very huge also. So the product of their masses is huge. Therefore, the force of attraction will be bigger. Let's take an example of of this top and this marker pen. The force of attraction is very low, near zero, and I think it is 0 point something something, but it's not nothing. But there's a force of attraction between these two bodies. But that force of attraction increases with the increase of mass. But he said inversely proportional to the square of their distance. The nearer the objects are, the more the force of attraction. That means when the body are too near or close to each other, there is more force of attraction. Okay, let's proceed with the question. Therefore, it will be force is directly proportional to m1 times m2 over d squared. When you remove this proportionality sign, you'll get force is equal to g m1 times m2 over d squared. Now this was the formula of the force of attraction. This was according to Sir Isaac Newton. But Sir Albert Einstein said, give me a break. I think there is no such thing as the force of attraction which pulls people or which pulls object, but there is something pushing us. Let's say like we humans, we are not pulled by the earth, we are pushed by something down toward the earth. And he said that thing is space-time. Okay, let's take a look at space-time. What is space-time? According to Albert Einstein. Albert Einstein produced many of his articles when he was 30 something, and it was in the year 1905, 1916, and 1913. He changed the vision of the world on gravity. Okay, he said that all celestial body lie on space-time. It's like a piece of clothing and which holds a mango or a watermelon or an orange. It's like this. I'm drawing this into longitudinal section, I mean a cross section. It is like this. Okay, and 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 there's some crossing because it is a four-dimensional figure, the space-time. Okay, now this crater over here is formed by a sun, because the sun is very huge. Therefore, a sun forms a very great crater. But this small crater over here is for the planet. So there is no such thing as gravity pull, because this crater over here will hold the planet and it won't let it escape from this crater, because there is a sun here. But doesn't mean that this sun pulls this planet. It is because of this crater created by the sun. So the planet won't escape this crater unless the sun vaporizes or the sun disappears. Okay, maybe if you didn't grasp that, we're gonna take a look in another form. I said space-time is like a carpet. Doesn't mean that suns and other bodies just float on space. They are on something, which is space-time. Okay, now this is the sun, and this is the planet. Okay, now this sun creates a huge hole from the space-time. As I said before, space-time is like a carpet or a piece of clothing with mangoes on top, always watermelon. Now, if you put a watermelon on a piece of clothing, it will sink more than the mango. That means the sun is similar, or the watermelon is similar to the sun. Now, when the sun is on the space-time, it bend this four-dimensional structure of the space-time, right? And this planet ain't far from the sun, so they're just near. Due to that crater, these planets won't escape, okay, or won't go away. But what if the sun goes away, or what if the sun disappear or vaporizes? What will happen? Okay, this is the sun. When it vaporizes or disappear, do you see this space-time? Let's say the sun disappears, then this space-time will tend to come up, filling this gap which sun has left. And when the space-time fills that gap, it will be like flat. You know what I'm saying? It will be flat. And when it is flat, due to that covering of the space left by the sun, it will create some waves. It's like you drop a piece of stone into the river. It will form some ripples, and when it forms, those ripples are exactly the same as the waves formed by the space-time due to the disappearance of the sun. Now those waves will disturb the movement or the revolutions of the planets, and that will make the planet, let's say the planet was orbiting anti-clockwise, and then those waves will push it out of its way, and it will go the other direction. But Albert Einstein calculated that the speed of light and the speed of gravity are exactly the same. Due to this experiment, they assumed that what if sun disappears? What will happen? And they said we will all face loss of light and loss of gravity at the same time. And I think this is just a nutshell of space, time, and gravity. For more information, check Michio Kaku. Is one of the theoretical physicists in the world. He's so brilliant. He explains more about space, time, and gravity, but this is just a nutshell for people trying knowing this. And if you have liked the video, give it a thumb up or press the like button, and you can hit the subscribe button for more videos to come. The next video will be why is the sun yellow and why do we see the sky is red in the evening. So be with me. I'm signing off. Emmanuel from Answer Seekers and Information Sharing.org. Thank you very much.